So I've just been asked to give a few notes or thoughts on the use of AI and machine learning in climate services. Just my background is that of a statistician, come from originally classical statistics, forecasting in general. I've moved into a lot of stuff related to seasonal weather forecasting, so that's been my experience. Um, just some general thoughts about data science, climate services, et cetera. I think it's a great time to be working in this domain. There's just a lot of data coming online. There's a lot of open terrain, and there's a lot of excited partners to be working on things. I'm in a research institute. There's a lot of people that do sort of research related to the sort of remote sensing, so satellite imagery, et cetera. And 10 years ago, they started talking about deep learning. It was a thing they were dabbling in. And now it has completely taken over. They just do that. And I really think there's a lot of links between what goes on in Earth observation systems and what goes on in climate services and weather prediction. And so I can actually see a lot of these methodologies coming into play here. And we're already beginning to see some of that. So we're seeing some advanced methods applied to NWP, et cetera. I have to be honest, though, working in this domain, I encounter a lot of what I'll call institutional suspicion. So there are the people who make the NWPs, and they really like the consistency of these models. And one of the problems I've always had with them is finding out what do they mean by consistency. And if we knew something more about that, we might be able to reconcile a lot of these differences. The final thing I'll say is, I approach everything as data. So there's data from reanalysis and observational systems, but I also think of the NWP output as itself just data. And let's use all of it. So we haven't observed that much of the Earth system, but we've generated quite a lot of forecasts of it. And because we know those forecasts come from the solution of sort of differential equations, I think we can use that information to guide our models. I'll just loop through some of the research trends I've observed. The first one is what I'll call the same but more complicated. Statistical post-processing of numerical weather prediction output is an established field. And we've seen a number of researchers come in and try and replace sort of standard statistical sort of regression type MOS approaches with neural networks. There's some improvement in skill. Interpretation of these models is often lacking. It's usually very easy to say what a MOS model does. And space-time consistency, it's not that it's killed, just it's not guaranteed to be preserved by these methodologies. Another line of approach is to replace NWP entirely. This is a very interesting recent paper that trains a convolutional neural network on reanalysis data and just takes this forward. And this is the paper I was talking about, where they're able to generate a 6-week forecast, 300 member ensembles in about 3 minutes on a laptop. There's no guarantee of physical consistency right here. They're just focused on essentially the global pressure system, although that's a reasonable place to start. And the skill in the first 3 weeks is not as good as the NWP models for subseasonal. It's on par with them at the 4 to 6 week time horizon. One thing that I'm very interested in, it comes back to this consistency notion. Here are 4 images of individuals, and these individuals don't exist. They are the output of an algorithm that is trained on pictures of faces, and these look to me like people. And I think this algorithm type, this generative adversarial net, could be used to produce weather fields that would fool a meteorologist in its consistency. And I think that's very interesting, because it means that if we can condition these GANs based on things we know, for instance, teleconnections, et cetera, perhaps we can generate realistic looking, high dimensional, consistent weather forecasts using a much smaller feed forward system. And the place that I think this could be especially interesting is in this this desire to blend the output from subseasonal, seasonal, and even decadal forecasts into one consistent stream. Just to conclude, AI has definitely generated a lot of buzz. It seems promising, especially given what my colleagues in Earth observations have done with it. My feeling is the observed Earth system, so just pure reanalysis data, et cetera, has nowhere near enough observations to work in practice. You need millions of observations for these to really work. But we have at this stage generated quite an impressive amount of model output data. And so I would like to see a merge of these two, using NWP as both a way to start training artificial intelligence and also to guide the forecasts that come out of artificial intelligence. Thank you.